Hello friends. So pretty recently I was actually watching Fast 10 and then I realized that if Vin Diesel can explain how space and how astrophysics works with cars, why can't I explain that how system design components work with cars? So today in this video I'm actually going to talk about that what are the system design components you need to take care of while designing your system, whether it could be in your interview or in your actual job. On top of that, I'm going to explain each one of them with the analogy of how it represents in your car, because many times I have found that it becomes difficult to visualize how each things are related and what is the purpose of every single component. So I'm just going to give you a brief overview across all of the components. So first let's start talking about that what is a UI. If you are designing any system design, you first have to must consider that how the users are going to interact with your system. Now think about a car. What are the first things that you do when interacting with your car? Well, number one, definitely its exterior, its outlook that matters the most. On top of that, if you are driving a car, you always need to have some way to communicate with the car that, hey, these are the things I want and I don't care how, go get it done. Whether it could be as simple as something like guiding a radio or putting a music in your system, to much more complex things that your car telling you that, hey, your left tire is actually punctured and there is some issues in the broken, or your engine is not working and suddenly the engine light pops up. So all of these things are actually considered as UI, that is guiding you and letting you communicate with what is happening behind the scenes. Now let's go to some more important concepts. One of the most important things that you need to consider in your car is that how is your engine. You see a lot of people talking about that, hey, this is this V8, V6, 220 horsepower turbo, I don't know what all of those terminologies they use, but that is essentially the meat of your car that keeps your car moving forward. The pistons are running, they are pumping in fuel or either electricity or whatnot, but still they are making your car run on the speed you want. And that in the system design terms is actually the application server or the application backend that basically runs all the processes computing that whatever you are requesting and then keeps moving forward. So if you want to think that what does a backend represents, it represents the engine of your system, that how everything is going to come together, how it's going to communicate. So all of these computing is actually happening behind the scenes without you knowing it. But because you don't know it doesn't mean it's not happening. And that is the same concept in the system design, that whenever you are designing your breakage or your backend, you need to make sure that what are the exact requirements. Are you designing a car like Bugatti Chiron that needs to run at 200 miles an hour, or are you designing something that is like a Hyundai Civic where you need to get the most mileage rather than focusing on achieving the 200 mileage speed at the maximum level? And that is going to change your design principles drastically. Same thing is going to happen with your actual system that whenever you are designing your backend. So that is really important. Now one of the next very important component in your car is that how it is going to get the fuel. Now fuel could be in two terms, whether it could be electricity or whether it could be gas. In either case, you will need to feed something to your system or to your car so that it can use that, leverage that and keep burning forward. If we see the same concept in the system design, essentially we are talking about database. Now database is the most important part of any system design. It needs to be secured. Same way your gas tank needs to be secured, otherwise if it comes into the contact with the air, either your gas evaporates, or if it, worst case scenario, if it comes into contact with the light or fire, essentially boom, your car is going to go up in the flames. Same way for your application, if it is not secure, maybe someone can misuse it, like you take use of any glitches, or even worse, if it comes into the hands of the hackers, essentially hackers can completely destroy your company. On top of that, you need to understand that what type of constraints you need for your gas tank, how big you want it, what type of fuel you are going to put it in, what type of security mechanisms you are going to have, how it is going to open, how it is going to push the gas into the engine, how much amount of gas you want to put it into the engine. And the same considerations are put into the fact whenever you are designing your database as well. What type of database you want? You want relational, you want no relational, SQL, no SQL, Postgres, MySQL. You want your database to be on cloud, you want your database to be on premises, how they are going to interact with each other, how secure the connections are, which applications needs what kind of data. All of these things you are also going to consider whenever you are going to design your system design as well. So again, just like gas tank or just like electricity charging your vehicle, data is the driving force, and you need to make sure that you consider a lot of things before coming on to your database. And whenever you are discussing your database with your interviewer or even in your system, you will have to first understand the trade-offs of different types of data. So trade-offs such as, if I'm going to use a gas car, the benefit is that I'm going to be able to drive to anywhere. Most likely I'm going to find the gas, and most likely it is going to be within the reasonable amount. But if I'm going to use an electric car, what are the trade-offs? Again, I'm going to be saving environment. I'm going to have some issues where I won't be able to reach to longer distances in one go, and initial cost could be expensive, but in the long run, electric vehicle are going to be cheap. So these are two completely different trade-offs. I'm not saying that one is good or the other one is good, but depending on your situation, you can make the decision. Same thing you're going to do with your system design while considering your data. Now let's talk about one of the important features, that is load balancer. So how do we define load balancer in terms of car? Of course, why your car is not running on just one wheel? Because it won't be able to take the load. It won't be able to separate the load. It won't be able to distribute the load. The car is going to be wiggly. Same way, you don't want your entire application to running on just one server. Why? Because what if that server crashes? What if it is not able to handle the load? Hence comes the concept of load balancer, where same type of resources are being controlled by some component or some mechanism that makes sure to distribute the load. Same way the tires and the axles does. Because we have 4 tires, 2 in the front, 2 in the back. They do multiple functioning. So all of these things are exactly needed for the car, and that's why we have multiple vehicles. And the longer vehicle there are, the longer amount of tires we use. Same way, the bigger and the more complex systems there is, we are going to use more amounts of load balancers in between to distribute the load, to make sure that we are not facing any issues. Now let's talk about a specific concept that most likely you are going to use in your system design, but not really likely you use in your actual car, and that is the use of caching. So caching can be understood as the nitro boost system we have in typical cars. Now normal everyday people, we don't use nitro boost, we just have regular cars and we keep driving and keep moving forward. But if you see the racers, or especially Vin Diesel, our Greek god of cars, he always had one nitro in his system, and that is to give that extra boost to the engine, and it keeps on pumping forward. Same thing is what caching is. Caching basically enables us to retrieve some information rather than searching it in the data. It allows it to get it in between, which is meant to be very fast, and also it is meant to have a least amount of latency, which means we can complete our transactions in the fastest manner possible while saving so much time in between. So whenever you are designing your system design, make sure that whenever you need to take care of really fast transactions, you put caching in between. That whenever there is a need to have the fast retrieval without any wait or without being relying on the database towards the end, you need to put some stuff into the caching. And also because caching is pretty expensive to get, so that is why you don't want to put too much into the cache. You only want to put that gives us the best return of investment of all the stuff we are putting into the caching. And now last thing is data consistency. So what data consistency means is that you need to make sure that all the components in your car are working in tandem with each other, which means car is only pumping in fuel into the engine after it realizes that the car key has been turned on. If the engine is shut off and the gas tank keeps on pumping fuel into the engine, what's going to happen? It's going to erode the engine, or worse, it's going to break down the entire car. Same way, you don't want some stuff happening out of sync, and that is where data consistency keeps into the effect. Let's say that if you're making a financial transaction from one bank to another bank, you don't want the money to be deposited into the other bank if the money has not been retrieved from the first bank first. So that is the example where you need to make sure that the entire steps are followed to the end and same thing we need in our car as well. And whenever you are designing your system, make sure that if there are dependent systems in between, you are always taking care of consistency. And basically that's it. These are the main concepts you need to consider whenever you are designing your system, and we are going to keep on talking about these components and different system design concepts, so don't worry about it. Feel free to let me know what could have I done to make this video better, and till then, sayonara.